Here you'll notice that we have a BCA type problem. So here our problem says in a single replacement reaction, magnesium metal reacts with hydrochloric acid to produce magnesium chloride and hydrogen gas. How many moles of hydrochloric acid are needed to completely react with 2.43 grams of magnesium? So the first thing I want to do is I want to make sure I want to annotate the problem. So looking at it, we can see, okay, single replacement reaction, not super important. However, magnesium, definitely one of our things of interest. It's reacting with hydrochloric acid. There's my formula. And we're going to produce magnesium chloride and hydrogen gas. So there's my reaction. So we want to make sure that we can translate that coherently into my reaction steps down here. So if we're looking at it, we said, okay, we have magnesium, and it's reacting with hydrochloric acid, and we're going to form magnesium chloride and hydrogen gas. Keeping in mind that hydrogen gas is one of our diatomic 7, so it should show up as H2. Next thing I want to do is I'll make sure my reaction is balanced. So I've got one magnesium on the left, one magnesium on the right. We're good to go. One hydrogen on the left, two hydrogens on the right. So we have to make sure that we have an equal number on the other side. So let's go back to start. One magnesium, still okay. Now I've got two hydrogens and two hydrogens. That's good. I've got two chlorines and two chlorines, so everybody wins. This is a balanced reaction. As we kind of continue to progress, now we have to start putting any numerical values we have into our BCA table. However, the only things that go into a BCA table are moles. So let's take a look at how we convert moles to grams to moles. So we have 2.43 grams of magnesium. Now in order to convert that to moles, remember that our target unit should go on top. So that's 1 mole of magnesium. And the thing we need to cancel, or the unit that we need to cancel, has to go on the bottom. Looking at the periodic table, we can see the magnesium has a molar mass, or the mass of 1 mole of magnesium is 24 grams per mole. So for every 1 mole of magnesium, it's 24 grams. Notice again, my units are diagonal, so they're going to cancel out, and I'm left with just the unit that we want. Because remember, the only thing that goes into a BCA table is moles. So now it's 2.43 times 1 divided by 24, which gives us an answer of 0.101 moles of magnesium. That's a value that it's going to end up going into my BCA table. This is my starting value for magnesium. This is how much that we have at the very beginning of our reaction. So if you notice in my BCA table, I've placed that mole value in our BCA table. So before the reaction runs, I know that I have 0.101 moles of magnesium, because previously we converted those grams to moles. So that's where this number comes from. Now, my problem says I'm going to completely react our magnesium, which means if it's going to completely react, at the end we're going to have none left. Now mathematically, the way to go from any number to 0 is to subtract that number again. So now our change column is complete. There's a couple of other things that we can put in here, though, to kind of complete this BCA table. So remember, this is before the reaction runs. So before I've done anything, we can't have any product. If we have any of the products before we do anything, then there's no reason to run the reaction. We already have what we wanted. So we've got 0 of both of those things in the beginning. Now we have to determine how we fill out the rest of our BCA table. We have to figure out what all of these other values are in order to make sure our table is complete. So the first thing we want to do is we want to start with the number that we're given, which is this 0.101 moles of magnesium. So here's my starting value. Remember, I started with 0.101 moles of magnesium. Now I have to kind of go somewhere else. So let's say that I want to change all of my magnesium into magnesium chloride. So the unit that I want to get rid of, again, has to go diagonal. And the unit that I'm trying to get to should go on the top. So in this case, we're trying to get to magnesium chloride. So our units are diagonal, they're going to cancel, and we're left with just this moles of magnesium chloride. Now we want to look at our coefficient comparison. So remember that there's a 1 that's implied that's in front of each of those numbers. So for every 1 magnesium I put in, I should get out 1 magnesium chloride. We can translate those numbers down here into our equation. So for every 1 magnesium chloride, I should have 1 magnesium. So when we're all said and done, 0.101 multiplied by 1 divided by 1, I ended up with 0.101, but now this is our unit, moles of magnesium chloride. That number is how many moles of magnesium chloride we're going to create with this reaction. So we can put it into our BCA table. So keeping in mind our last calculation, we found that we were going to create 0.10 moles of magnesium chloride. Mathematically, the way we go from 0 to any value is by adding that same number. So we're getting closer and closer to being done. Next thing we want to do is we want to go from our starting value, which is still magnesium, to hydrogen gas. We're going to figure out how much hydrogen gas we should be making in this reaction. So we're again going to start with the value that we're given. So in the beginning of the reaction, we're started with 0.101 moles of magnesium. Our goal is to get our moles of hydrogen, though. And we got to get rid of our moles of magnesium along the way. So you notice again, these units cancel, they're diagonal from each other, and we're left with just the unit that we want. This is when we go back to our reaction, we look at those coefficients and how they compare. Again, remember there's a 1 that's implied in either of these locations. So for every 1 magnesium, we're going to get 1 H2 that comes out. So we can translate that and be like, okay, for every 1 hydrogen, we should get 1 magnesium. So 0.101 times 1 divided by 1, we should be producing 0.101 moles of hydrogen gas. This is another value we can put into our BCA table. So again, remember from our last calculation, we found that we were generating or creating 0.101 mole of H2 gas. Again, we can fill out this one because we know to go from 0 to 0.101 mole, we have to add that value. So here's our last column that we have to kind of finish or to kind of construct. So here are the values that go into this one. Can you figure out where they came from?